Okay, in this video we'll be looking at finding the minimum spanning tree from a table. So we've got, um, we've learned the Prim's algorithm for a graph just before to figure out how to find a minimum spanning tree. We use the same process, Prim's algorithm, but for a table in this case. And the steps are quite similar. So we're going to look at step one. Step one says choose the first vertex, delete its row, and mark its column with an arrow. So to mark it with an arrow, I draw an arrow going down. And so hopefully that loads up in a sec. And then I want to delete that row. So I just draw a line going across that now. So it says choose the first vertex, delete its row, and mark its column with an arrow. So we've done step one. Step two says scan all marked columns. In this case, there's only one marked column. And for the lowest non-zero entry, and a non-zero entry might be, say for instance, that these dashes here, it's like a non-zero entry. So what we want to do is find the lowest non-zero entry. Okay, so if I had to put a circle around anything, it would have to be the 300. Okay, now it says and circle that entry. Now there isn't a tie, it's clean 300, so we're up to step three now. Delete the row containing the circled entry. So in this case, row E gets deleted, so just draw a line across. And it also says mark the corresponding column. So now we're looking from both node A and node E. Okay, so looking from node A, node E, what's the lowest? Well, we can see in node A there's 310 and node E it's 350. So we choose node A again, connecting up node C, cross the row off, mark it with a column, with an arrow, in the column. Now we're looking from all these nodes. Now a circle means we've chosen it, so we ignore them. Node A just has 620, and node G is 550, and E, we've got a 360 there, so we'll choose E. Now we've hooked up node G, so we cross off G, and we mark G. So now we've got 4. The lowest now looks like it's going to be 380, which is node F. We cross out node F, we mark node F, and then we scan again. The lowest now looks like it's in the new column F, which is connecting up D. So we cross off that row there, and now we highlight D. We do the same process, finding the minimum. A's got none left, B's got 550, D's got 430, E's got 530, F has 330. So the easiest way of connecting up B is through F. Cross a line, draw an arrow. Okay, so there we go. We've just actually made, using Prim's algorithm, a minimum spanning tree. Now how can we check this? Well, we've got A, B, C, D, E, F, G. We've got 7 nodes. So let's just say I draw those out. Okay, so A, B, C, D, E, F, G. Let's see if this is a spanning tree. So it says here that A is connected to C with 310. A is connected to E with 300. And F is connected to B with 330. We've got F connected to D with 210. We also have E connected to F, and we have, and that's 380, and we have E connected to G, which is 360. I'll use a different color because it's getting a little confusing now. Now we can see this is a minimum spanning tree. There's no cycles and everything's connected. So how do we find the minimum value? We add up all the circled values. So we have 310 plus 300 plus 330 plus 210 plus 380 plus 360. Adding these up, I get 1890, and then I'm going to put units as a reminder that we should always put our units. Okay, so 1890 units. There we go. We've completed our first minimum spanning tree from a table using Prim's